Hello, welcome everybody. Here are your class notes on lesson 6.1, angles of polygons. So don't forget, as I'm speaking here, that you should write down your title, angles of polygons, and lesson 6.1. So a couple comments on this slide. Besides writing the title down, I'm going to have you get down a formula in a second, so you don't have to really write anything from down here, but it's kind of clever before I tell you what this formula is to kind of look at some patterns. So the patterns are, if I had a triangle, just a regular triangle, we know from last chapter that the triangle has three sides, and you can make one triangle out of a triangle. Well, that makes sense. And we also know that all three angles, when you add them, are 180 degrees. Now remember that. Now if I had a quadrilateral, which is a four-sided figure, polygons are enclosed shapes that have three sides or larger. So a triangle is a three-sided shape. A quad, meaning four, quadrilateral is a four-sided shape. Now if I connect these two corners, I have two triangles. So I have 180 degrees if I add up these three angles, and another 180 if I add up those three angles. So 280s give me 360 total degrees if I add up all of the angles in a quadrilateral. So then I'm going to jump to a hexagon. Pentagon is a five-sided figure, but let me skip that one. Let me jump to a hexagon because I have a picture here. This picture is my hexagon. So if I would break up the hexagon into triangles, because I know triangles is 180, then I have one triangle, two triangles, three triangles, four triangles. So I have four 180s, which equals 720. This is kind of interesting because a hexagon has six sides, yet I can make four triangles. 6 minus 2 gives me 4. This is interesting that if I have four sides, I make two triangles. So I subtract the 2. So that lends ourselves to... So now for this slide, all this slide tells me is that polygons is a general name for any enclosed figure. This is a polygon, but it's a special polygon called triangle. This is a polygon, but it's a special polygon because it has four sides, so we call it quadrilateral. Five-sided shapes are called pentagons, six-sided shapes are called hexagons. These first four, triangle, quadrilateral, pentagon, hexagon, you should definitely know. And then another popular one is octagon. You should definitely know that. Well, heptagon's a little rarer. I think you probably should know that. But then this nonagon, decagon, and dodecagon, and anything over 12, there are names for them, but we're just going to call them a 13gon or a 14gon. That means they have 13 sides or 14 sides. Just a vocabulary slide for you. That is this formula right here. This formula is how you figure out the total number of degrees inside a polygon. So that's called the polygon interior angle sum. So I'm going to give you a moment to write that down, and I'm going to erase this so you can kind of see what I'm talking about. And the formula you need for the sum meaning add, of the inside angles of any polygon is you take the number of sides, subtract 2, and multiply it by 180 because that's how many triangles you can fit. So I said I was skipping pentagon before. This is a pentagon. Why is it a pentagon? Because it's got 1, 2, 3, 4, 5 sides. So how many triangles can I make inside of here if I connect this corner? If I connect this corner, I can make 3. That's why I take 3 180s to get my total degree measure, which is 540. So where does the magic 3 come from? The number of sides take away 2. And the reason why it's kind of take away 2 is because you can't make a polygon with two sides. So those are 2. You can't make that until you connect them to make 3. So that's where the 2 comes from. So basically, if you don't really understand that, all you have to do is know that formula. So now for example 1, Our mission is to find the sum, meaning the addition of the measures of the interior angles in a convex nonagon. So a nonagon, if I went back, that's a 9-sided figure. So what I'd like you to do is use the formula to figure out how many degrees a nonagon has. And then I'd like you to use this picture here and the formula, because now it's no longer 9 for a nonagon. This has 1, 2, 3, 4 sides. You're going to use the 4-sided figure and total these up. Now remember, sum is the key word. It means you have to add them all. So I'm going to give you a moment to give that a try, and then I'm going to show you the solutions on the next slide. Feel free to pause if you'd like to try it on your own if you know what you're doing. Okay, here are the solutions. So for number 1, nonagon I said was 9 before, so I use 7. Why do I use 7? Because you need to do 9 minus 2. And then multiply that by 180, you get 1260. Then for the quadrilateral here, you have 4 sides, so you have to add up 4 of the angles. 1 angle, 2 angles, 3 angles, 4 angles, and you set it equal to this magic number 360. Well, why 360? Because 4 minus 2 is 2, and 2 times 180, the formula from before, all that work is right here, and that's where the 360 comes from. And then you combine your like terms, so if you look at these red underlines, 11, 11, and the 5, those are x's, that becomes 32. And then the I think that's a green color, green underlines are the 4 and the 4, and then that gives you 8, and then you just solve and you get 11. Now it did ask for the measure of each angle, so once you get 11, you substitute it back in there. 11 times 11 is 121 plus 4 is 125, and likewise you substitute it in there. One word that you're going to encounter is this word regular. Now we talked a little bit about that in the quarter 1 project. Regular means all sides are the same. So basically for a triangle, a regular triangle is also called equilateral because all 3 sides are the same. If I had a quadrilateral and it was regular, all 4 sides are the same, we call that square. If I had a pentagon, all 5 sides are the same, and you just kind of draw it and do your best. There's no other special name for it, it's just called a regular pentagon, etc. So regular means all sides are equal, and all angles are equal. So here's example 2, and this happens to deal with a regular pentagon, means all sides and all angles are the same. So reading this, a mall is designed so that 5 walkways meet at the food court that is in the shape of a regular pentagon. Find the measure of one of the angles. Well, if you kind of take a look at this pentagon here, and you figure out the total degrees, that means n minus 2 times 180. That'll give you the total. Then to find each one, because they're all the same, because of our word regular, you just take this answer and divide by 5. So feel free to give that a try. That's how you deal with regular polygons. Here is your solution. So 5 sides minus 2 times 180 is 540. You take 540 divided by 5. Each of these little angles there is 108 degrees. And I mean, this is all focused around architecture, so of course you could definitely think of this as being an architectural problem in terms of when people are constructing this food court, how to determine the angle measures to make these little walls. Last question. Last question deals with a new theorem. It's called the polygon exterior angle sum. To do exterior angles, if I had, like, let's say, a pentagon. I don't have a pentagon in that picture, but let me make one. 5 sides. An exterior angle would be extending this side, and then that exterior angle would be, like, right there. So for my picture here, when I look at it, each one of those is an exterior angle. Now here's the cool, magical thing about exterior angles. It doesn't make any difference what type of polygon it is. Pentagon, hexagon, triangle, 15-gon, 1,000-gon. every polygon, the sum, which means addition, of all of those angles is 360. So for this one, this has 1, 2, 3, 4 sides. So this is a quadrilateral. I've extended all the sides to make these exterior angles. You know that when you add all 4 of those, you're going to get always 360. The insides depend on this formula, but the outside angles is always 360. Feel free to pause this one. Try to find x in example 3. And here's a solution. All 4 angles added up to 360. Add your x's, you get 17x, subtract 139, divide by 17, and you get 13. So x is 13. Now, I did not ask you to find each angle, but if I needed you to, you substitute a 13 in for x, and then that angle, for example, would be 2 times 13, or 26 degrees. That's it. Thanks for listening.